Okay, welcome back, Algebra 2 students. In this video, we're going to cover section 2.4, and we're going to solve systems of linear inequalities. So, the first three sections were focused on solving systems of linear equations, and so we had three equations with three variables. Now we're going to go back to just 2D, where we're working with only two variables, but we still have multiple, more than two inequalities to worry about solving. The first thing, though, is that we need to determine if we're given some point, if that is going to be a solution to a given inequality. Um, and so just like before, like if we wanted to check a solution for one of our systems of equations, we can plug x and y back into, or x, y, and z, back into the original system. And if all three equations were true, then we would say that that was the actual solution. That was our solution. And so with this, it's going to be the same thing. We're going to plug in x and y, so 1 and 2, swap it out in each of these inequalities, and check, is each inequality true when we do that. If all three of them are true, then we will say that yes, it is a solution. If any one of them, it only takes one of them, to be false, then we're going to say that this is not a solution. So as soon as one of these is false, we can go on to the next one, because we can say that this is going to be not a solution. So if I start with the first inequality, we have y greater than or equal to 5x minus 6. So let's swap in, this is our x, this is our y. Let's see if this is true. We have 2 is greater than or equal to 5 times 1, and then minus 6. Let's see, well, we have 2 greater than or equal to 5 minus 6, which means that 2 is greater than or equal to negative 1. And 2 is greater than or equal to negative 1, so that one checks out. Okay, but now we got to check the other two. If I do the second one, I'll do it down here. We have, let's see, y is still 2, and we're saying that y is less than or equal to 3 times, not 2, that's going to be a 1, because x is 1, plus 1. Does this check out? We have 2 less than or equal to 3 plus 1, so 2 is less than or equal to 4. Is 2 less than or equal to 4? Yes. So the second inequality checks out. And now let's check the third one. That's going to be 2 greater than negative 1 plus 2. And now we have 2 greater than negative 1 plus 2 is 1. And that checks out. So, yes, because all three of them are solutions, we say yes, 1 comma 2 is a solution. And there we go. That's number 1. Number 3, pretty similar. We got to verify that each of these is true. Starting with the first one, we have 0 is greater than 2 minus 5. Remember, because this is x, this is y. And let's see, well, 0 greater than 2 minus 5 is negative 3. 0 is greater than negative 3, so that checks out. All right, so first one checks. Let's see what the second one does. That's going to be 0 is less than or equal to 2 times x, which is 2, and then plus 1. We have 0 less than or equal to 4 plus 1, and 4 plus 1 is 5, so we have 0 is less than or equal to 5, and that checks out. So second inequality checks. And let's check the last one. We have y is less than 0, less than negative x. Well, I don't know why it said 0. So y is 0 less than negative x. We have negative 2, and then plus 3. That means that 0 is less than 1. That checks out. Okay, so first three checked out. that means that since this point satisfied each of these inequalities, then yes, we can say that yes, 2, 0 is a solution. And that's number 3. Number 5, does this one work? I don't know, let's find out. Let's see, we have 5 is less than or equal to -2 plus 3. And let's see, so 5, remember because this is x, this is y. So we have 5 less than or equal to -2 plus 3, and that is 1. 5 is not less than or equal to 1. That is wrong. And because this first one was wrong, we don't even have to check the other two inequalities. We can say no, -2, 5 is not a solution because it makes at least one of the inequalities true. False. So as long as one of these inequalities is false when we plug in this point, we can immediately conclude that it is not a solution, and we can move on to the next one. And because I'm a jerk, I included one where we have 4 inequalities that we have to check, and let's see what's happening here. Let's see, so we have 2 times x and y. So 2 times x is 2 times 1 plus 3 less than 5. We have 2 times 1 is 2 plus 3 less than 5, and 2 plus 3 is 5 less than 5. So, is 5 less than 5? No, this is not true. Now, if I had 5 less than or equal to 5, then that would check out, because this means 5 is less than 5, but that's false, but this also means 5 could be equal to 5. So because it is 5 is less than or equal to 5, then this would be true, but 5 less than 5 would be false. So the first inequality does not check out for this first one, and so we would say that no, 1, 3 is not a solution. We don't even have to check the others. Now for yours, for the homework, I don't know. They could all be true. You might have to check all the way down to the last one and see if that one is true or false. But again, if any of these are false when you're checking them, then your answer is immediately going to be no, that it's not a solution. And if every single one of them is true, then that is when you will have a solution like these. But you have to make sure that all of them are actually true. Now we're going to get on to graphing. So before we actually start graphing these, we actually need to recap how to graph vertical and horizontal lines. So if you remember how to do that, that's great. You can probably skip ahead. However, this is just to make sure that everyone is on the same page. So if I have my x and y axes like this, and I want to graph, say, y is equal to 3, that's going to be a horizontal line that goes through the point 0, 3. So the y-intercept of this equation, y equals 3, will be whatever this number is, so 3. You can kind of think of this as a special case of the equation y equals 0x plus 3, because 0x is just going to be 0, so we really don't need to write 0 plus 3, and hence we can just write y equals 3. But you can think of this as being, like if we're graphing in slope-intercept form, a line that starts off with a y-intercept of 3 and then it has no slope. And remember, if your slope is 0, then that means that it's going to be completely horizontal. So it's one way that you can think about this y equals 3. It's going to be this horizontal line where the y-intercept goes through whatever that number is. Now, what if, on the other hand, we're graphing, say, x equals negative 2? So how do we graph y or x is equal to negative 2? So it turns out that this is going to be a vertical line, and it's going to go through, similar to for the horizontal line, on the x-axis, it's going to go through this point, negative 2, comma 0. So whatever this number is right there, so I'm going to underline that in blue. Whatever this number is right here is going to be the x-coordinate of wherever it intersects on the x-axis. And similarly over here, when we have a vertical line, y is equal to 3, it's going to be whatever the y-coordinate is where it intersects on the y-axis. So, in a nutshell, vertical lines will be in the form of y equals a number, b. And then horizontal lines will be in the form of x equals a number. I'll just call that a. But this right here is super duper important for us to recall because a lot of the problems on your assignment here require us to graph horizontal and vertical lines. Now, what about shading? What if I give you, let's see, maybe x is greater than or equal to 5? How would that look? Okay. Well, let's think about that for a second. If we were just working on, say, the number line, we would find wherever 5 is on our number line, we'd have a closed circle, and we would say that this is, because it's greater than, it's shading everything to the right, like that, all the way to positive infinity. So it turns out that what you're doing here, when you're graphing this in 2D, you can think of this as extending from that 5 and shading everything to the right like that. So it's kind of like what we were seeing when we were graphing inequalities in chapter 1, except now we're extending this idea into 2D space. And so if we would shade to the right, we're also going to shade on a plane everything to the right of whatever that number is. So when I see x is greater than or equal to 5, I first graph that vertical line at x equals 5, and then I would shade everything to the right of that. And it would look like that. So then what does it look like if we do say something like x is less than 2? Well, if we were to graph this in just 1D or on a number line, we would find wherever 2 is, we would have an open circle, and we would shade everything to the left. And so it'd shade everything over there, and that would be our solution. If we extend this idea into 2D, we're going to use a dotted line where we would, anytime we have an inequality where it's just less than or greater than, we're going to have a dotted line. And same idea, we're going to shade everything to the left here. So everything over here still gets shaded. The important thing is that we have this dotted line here. So this is how we would shade inequalities where x is less than or greater than. And then y, what if we have, say, y is greater than or equal to -3? Well, let's go back to our 3D graph, or sorry, not our 2D graph. First, let's just graph y equals 3. So we know that this is going to be a horizontal line that goes through this point 0, comma 3, -3. And when we see greater than, when you have y, is going to shade above. So greater than or equal to. So greater than, aka that one, or equal to, is always going to shade above. So we'll always shade above when we see a greater than. And so we graph our line, and then we shade everything above it, like that. And so what happens if we have less than? So if I have, say, y is less than 1 on my 2D graph, I graph y equals 1. Whoop. And actually, we don't want to make a solid line. Because this is just less than, we're actually going to make a dotted line. So anytime you have just less than or just greater than, but not that little bar underneath it for equal to, this is always going to be a dotted line. So we think of this as like graphing y equals 1. We make sure it's a dotted line because we don't see the little or equals bar under there. And then because this is less than, and of course this point right here is 0, 1, because this is less than, it's going to shade everything below. So everything down there is going to get shaded. So anytime you see less than or equal to, so in other words, that one, or with the little bar, doesn't really matter, we're going to shade below. So now that we have that information out of the way, we're actually ready to tackle the problems that we have, starting with number 9. And so with these, I'm going to actually shade these with 3 different colors, and I recommend you do the same thing. So in this first one, I'm going to shade with black. So with y less than 4, we remember this is going to be a horizontal line, and I'm going to find where 4 is. And I know this is going to be a horizontal line, and I'm going to use a dotted line because it just has the less than symbol. It doesn't have that little bar underneath. So that's our first inequality, but we need to know which way to shade. This is less than, and less than means we're going to shade below. And so that means that everything down here, I'm going to try to make this as neat as possible with pen. There we go. So it's going to shade everything down there. Trying my absolute hardest here to make sure it's not too dark. Okay. So there we go. So that's going to be y is less than 4. The next part of this, I'll do in red. We have x is greater than -3. So I'm going to find -3 on the x-axis, which is right there. Because this is greater than, and it doesn't have the little bar there, I'm going to put a dotted line, because remember x equals a number is just a vertical line. And because it's greater than, but not equal to, it's going to be a dotted one. And let's think about this if it was a 3D graph. Sorry, a 1D graph. If it was greater than, then we would shade everything to the right, if we think about this on the number line. So remember, it looks like a little arrow, and so we would shade everything that way. Well, now that means that because we're shading in 2D, we're going to shade everything that way. Okay, so now we have these two overlapping regions. We have one that's shading below y is equal to 4, and we have one shading to the right of x equals 3. The last one is we have that y is greater than x. So this, I recommend thinking of this as, remember, this is basically slope-intercept form. So if you think of this as y is equal to mx plus b, our slope here is 1, and our y-intercept, well, we don't see 1, right? So that means that our y-intercept must be equal to 0. So we start off at the origin at y is equal to 0, and then our slope of 1 means that our rise over run has got to be equal to 1. And of course, we can always represent any whole number like this as a fraction by just dividing it by 1. So our rise is 1 and our run is 1. And that means that every single square we're going to go over 1, up 1, over 1, up 1, over 1, up 1. And so what we're going to get, that it's difficult to see over the shading that I've already done. But over 1, up 1, over 1, up 1 is basically going to look like that. And it's going to be a dotted line like that. And because this is y is greater than x, thankfully anytime we're dealing with y like this and we have y isolated, greater than is just going to shade above. And so it's going to shade everything above like that. And so now we're ready to interpret our solution here. Our solution is going to be where all three colors are shaded. So notice that in this triangular region right here, we have all three colors. Over here we have just blue, over here we have just black, over here we just have red and black. But if we try to find where all three of these are overlapping, red is shading everything over here, black is shading everything down there, and blue is shading everything up there. This region in the middle is actually what our solution is. And I'm going to shade it in black, but I'm going to shade it darker. That way we know that, yeah, this right here is our actual solution. So everything in this little triangular region is where all three colors are overlapping. And you do want to make sure that you write, I'm not going to be a stickler when I'm grading this, but you want to make sure that these are still dotted on your borders. And I didn't even dot them that well because it got a little bit messy, but it's this region in the middle in this little triangle is where our solutions are. And so how we interpret this is that any point inside of this little triangular region will be a solution to all three of these inequalities. So any point inside of here will work. And so if I pick a point, say, out here, where I only have the red and the blue overlapping, this point, which would be -1, 6, will only satisfy the inequalities for blue and red. If I pick this point over here, which looks like negative 7 comma 7, it's only going to satisfy the blue inequality, but because there's no red or black being shaded over here, it won't satisfy these two. If I pick this point down here, it'll only satisfy the black inequality. If I pick this point over here, it'll satisfy both the black and the red, but it won't satisfy the blue. So that's how we interpret this shaded region here, is this shaded region where they all overlap, that's where all of your solutions are going to lie. And I do want to note that along the border of this solution, so like even 0, 0 here, actually won't satisfy the inequality because 0, 0, if I try, say, plugging that into the blue inequality here, if I have 0 greater than 0, kind of like that last example we did on the previous page of number 7, 0 is not greater than 0, so this doesn't check out, and that's why it matters to have the dotted line along this border, because if you have a dot along the dotted line, or a point along the dotted line, it doesn't satisfy it. It has to be a solid line. Because if it was a solid line, then it would be greater than or equal to, and that would be okay. So let's see what our other examples look like, and hopefully this will still continue to make more sense. If we look at number 11, now we do have to deal with these being in slope-intercept form, but that's okay. The first one we have, I'm going to do same scheme as last time. I'll do black first, and then our y-intercept is 4, so I'm going to put a dot right there on y equals 4, and then we have a slope of 2. So if m is equal to 2, then that means that our rise over our rise is 2, our run is 1. So from this point, I'll go over 1, up 2, over 1, up 2, over 1, up 2. And then I like to work backwards. Instead of going over 1 to the right 1, up 2, I can go left 1, down 2, left 1, down 2, left 1, down 2, so on and so forth. And I get this. And notice that this, because this is a less than but not equal to, it is just going to be a dotted line like that. And so last part of this is because it is less than, it is going to shade everything below right here. So because we have a less than, it's shading below this line. The next part of this is we're going to do in red. We have a y-intercept of -3, so I'm going to find -3. And then we have a slope of 4. So I go over 1, but then up 4. So because m is equal to 4, we have a rise of 4 and a run of 1. So we're going to go right 1, up 4, right 1, up 4, right 1, up 4. And then working backwards, we can go down 4, left 1, down 4, and I'm going to make a point right there. But this one is greater than or equal to, so it is going to make a solid line. So I'm going to try my best to make that straight. And there we go. And this one is saying greater than or equal to, so it's going to be shading above this line. So even though it's pretty steep, I can tell that, like, if I start, say, at any point, say this one, above this point would be over here. So I know that, okay, so I'm shading everything on this side of this dot. And so when I shade this, it's going to be everything above that line. Okay, so we're above the red line and below the black line. It looks like so far our only possible solutions are going to be kind of in this little triangular region so far. So now let's see what's happening with this final inequality. For the final inequality, we have a slope of 2, so still going to go up 2, right 1, but we're starting from -3. So starting from a y-intercept of -3, it's going to be on top of wherever this dot was as well for the red one, but our slope of 2 is going to be over 1, up 2, 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 so on and so forth. And we're going to get this line here. And because it is only less than but not equal to, it's going to be a dotted line like that. And now this one is saying less than this line. So less than is going to be everything below it. Everything below it will be down there. And there we go. So it may be a little bit difficult to tell, but the black shading was everything down here. And so they have some overlap above the red line, below the blue line, but remember the black is shading everything below here. So our solution is going to be a solid line right here along the red line, a dotted line where we had blue, and then it's going to shade everything in this little triangular region right here. This is going to be where all three of them overlap, and so this is actually our solution. Any point inside of this region, and of course this is going to extend down further forever and ever. So we'll continue to have this triangular region just go on forever and ever and ever and ever. But any solution inside that region, or any point inside of that region, will be a solution. Anything outside of it won't be. So for the same reasons, if I pick a point over here, it'll only satisfy the red inequality. If I pick a point over here, it'll only satisfy the blue and the black inequalities. I have to pick a point inside of this little triangular region in order to satisfy all three. Let's look at the next one. All right. So with number 13, we actually have to rearrange these a little bit. So I'm going to start with the first one. We have 2x minus 3y greater than -6. If I rearrange this, we want to get this into slope-intercept form. So we're going to move the 2x over to the other side. That's going to give us -3y is greater than -2x minus 6. So all I did was I subtracted 2x from both sides, and now I'm going to divide by -3 everywhere. When I divide by -3, remember your inequality rules. If I divide by a negative, I have to flip the direction of the inequality. And this is going to be y is less than or equal, or sorry, just less than. -2 divided by -3 is really just going to be 2 over 3x, because we have a negative over a negative. And if I divide this by -3, I'll write the -3 here too. So the -3's cancel, we get y. We have -2 over -3, which is going to be positive 2 over 3. And then we have -6 over -3, which is going to be plus 2. Now we're ready to graph that. And I'll write the inequality up here. So really we have y is less than 2 over 3x plus 2. And just so we rearrange all of these just from the get-go, I'll rearrange the middle one real quick too. We have 5x minus 3y less than 3. If I solve for y, I'm going to move the 5x over to the other side. That's going to give us negative 3y is less than negative 5x plus 3. And then if I divide by negative 3, I got to divide everything by negative 3. That cancels. I have y. But because I divided by a negative, I do have to flip the direction of this inequality and make this a greater than. The negative 5 over negative 3 is going to be a 5, positive 5 over 3, x. And then positive 3 over negative 3 is going to be negative 1. So the next inequality that we have to graph is y is greater than 5 over 3x minus 1. And the last inequality that we have here is the x plus 3y greater than negative 3. And if we try to get the y by itself, we'll have 3y greater than negative x minus 3. So we just subtracted x from both sides. And now we're going to divide by 3. Now, because we're dividing by a positive 3 this time, we don't have to worry about flipping the sign here. We can just keep this as y is greater than, remember this is like a negative 1 here. It's like negative 1/3 x, and then minus, we have negative 3 over 3, so it's going to be a minus 1. So now the last inequality that we have to graph is y is greater than negative 1/3 x minus 1. Now we're ready to graph all three of these. And so with the first one, we have a y-intercept of 2, and then we have a slope of 2 over 3. So we have a rise of 2 and a run of 3. That means we're going to go right 3 up 2. So right 3 up 2, right 3 up 2, right 3 up 2. And then working backwards, same thing. I can go left 3 and then down 2, left 3, down 2, left 3, down 2. And because this is just less than, but not equal to, this is going to be a dotted line. And because it is less than, we're going to shade everything below this line. And of course, I have to angle my pen just right so that it doesn't, just, fill up the whole graph with just black ink. No, it's very light because we have multiple things to shade here. The next one, we have a y-intercept of negative 1, so that's going to be right there. And since since our slope is 5 over 3, it means we have a rise of 5, so we go up 5, but we go to the right 3. So 1, 2, 3, 1, 2, 3, 4, 5. They share this point right here, but then 1, 2, 3, 1, 2, 3, 4, 5. All right, and then working backwards, we can go left 3, 1, 2, 3, but down 5, 1, 2, 3, 4, 5. And then last one, left 3, 1, 2, 3, down 5, 1, 2, 3, 4. And I'll make up this point down here since that's about where the next point would be if our graph kept on going. Because this is just greater than but not equal to, we're going to create this dotted line here. And because it is greater than, it's going to shade everything above this line. So the shading is going to be everything up there. All right, and the last one in blue We have also starting at -1 for the y-intercept, but now we have a slope of -1/3. So a slope of -1/3 means that we're going to go and we're going to go down 1 and then right 3. So down 1, right 3, down 1, right 3, down 1, right 3. And then working backwards, we'll get these points as well. And this is going to be a dotted line because it is greater than, but it's not equal to. So we have a dotted line like that. And this is shading everything above because it is greater than. So shading everything above is going to look like that. And we see that we have this overlapping triangular region in the middle. And so I'm going to shade that in darker in black. And so we do have these dotted borders within that region. And then everything in the middle within there on the interior is going to be a valid solution. So any point outside of here, like if I just pick a point down here, it'll only satisfy the black inequality. If I pick a point over here, it'll only satisfy the red inequality. And if I pick a point, say over here, it'll satisfy blue and black. This will satisfy red and black. This will satisfy blue and red. But the only points, oh, and I forgot to note this one right there. Not too big of a deal. But the only points that will satisfy all three inequalities will be the ones within this triangular region. The last one, again, because I'm a jerk, I put 4 inequalities in one problem, but thankfully we only have well, these are a little bit simpler, so they're not like too bad. You know, with this previous one we had to rearrange a bunch, but with this one we just have some vertical and horizontal lines for the first two, so this is not too bad. For the first one I'll do in black. We have y is greater than or equal to 0. Well, that means that the y-intercept is going to be 0. So we have a y-intercept of 0. And because this is equal to, greater than or equal to, it's going to be a solid line. So it's going to actually shade everything along the x-axis. And because it is greater than, it's going to shade everything above. And there we go. So y greater than or equal to 0, horizontal line. It is a solid line because it is or equals to, and because it's greater than, we shade above. The next one, let's see. That one we have, well, keeping consistent, I'll do red next. We have x is less than or equal to 9. So we find that, you know, first this is going to be a vertical line because it's x, it's in the form of x equals a number. We're going to find 9 on the x-axis, and it's going to be a vertical solid line going through 9, or through x equals 9. And that one's going to shade everything to the left. So everything over here and I'm just breaking this up because I don't trust myself to shade across the entire graph in one go. But now that's going to be everything over there. Okay, so far we have this overlapping region above the x-axis, but to the left of x equals 9. Next, Now, on your assignments, this says 15. This was a typo. I meant to just write 5, or just type 5. So do correct that, or else you're not going to be able to really graph the x plus y is less than 15. So just replace that with a 5, just cross out the 1. But let's rearrange this for y. Thankfully, all we have to do is subtract x from both sides. We have y is less than, subtracting x, we're going to have negative x, and then plus 5. So this is now not too bad. Remember, this is a slope of negative 1 right here, and we can represent that as a fraction by just putting this over 1. And now that means that we have a rise of negative 1 and a run of 1. So we're going to go down 1 and then to the right 1. So first, let's find our our y-intercept, which is 5. It's going to be right there. And then we're going to go right 1 and then down 1. So right 1, down 1, right 1, down 1, right 1, down 1, so on and so forth. And we're going to get all of these points along there. I just realized I was doing this in black. Let's be consistent. These are blue, which I can erase these, but it's going to start erasing some of my shading, so that's probably not going to be too wise for us to do. But in blue here, blue, this is going to make a dotted line because we have the less than but not equal to, and it's going to shade everything below because this is less than. So everything over there is now shaded below. Okay, so now so far we have this kind of triangular region here. Well, I guess on your graph it looks more like a trapezoid, but below blue, above the x-axis, and then to the right of red. So it's kind of this region so far that looks like that. That's where all of our possible solutions are so far. The last thing to shade is this y is less than x. So for that, I have a green pen, but I don't have a barrel for it. So I just have the refill on it, but we're going to make this work. And is it dead? It is. Cool. So thankfully, I have another refill of green, but it's little. So let's see if this works. Yeah, that'll work. All right, so we got green. I don't know if you can hear my cat in the background, but this one is, just y. Let's think about this as like y is equal to x. This is in the form of y equals mx plus b. This feels ridiculous. But in this case, m is just 1, and b is 0. So since b is equal to 0 in this case, we're going to start at the origin, and then with a slope of 1, we're going to go up 1, right 1, up 1, right 1, up 1, right 1. And so we're going to get all these points along these points here. And because it is less than but not equal to, it is going to make a dotted line. And so because this is less than, it's going to shade everything below. This is so ridiculous. All right. So there we go. All right. So let's look at our solutions now. So we have to shade everything above the x-axis. That works. We have to shade everything to the right, to the left of x equals 9. We have to shade everything below the blue and everything below the black. It may be a little bit difficult to see, but the only region that satisfies all of that is this little triangle here in the middle. I wish I'd used colored pencils on this, but and I recommend you doing the same for that, is to use colored pencils for this assignment because it'll be a lot easier. I have some in my office in the little wire basket, so but use those. But we can see that yes, this everything above black, everything to the left of red, everything below blue, and everything below green, and we get this little triangular region. And so that's our solution for this set of inequalities. Now, the last few questions of this, you're actually working backwards. So you're going to figure out the inequalities that give this solution. So thankfully, these are a little bit easier to read than some of the graphs that we had to make. But let's start with, say, this one right here. I'll put a dot in black by it. So easiest thing to do is just to read these off in slope-intercept form. So we're going to say that this is y. And look, notice that we're shading above that. So because we're shading above it, we know that this is going to be greater than, and because it's a solid line, it's going to be greater than or equal to. And now we just have to figure out what the y-intercept is, which is -2. So we know that we're going to have -2. We know we're going to have the x. And now we just need to figure out what the slope is. And the slope of this is going to be, we do right 1 and then up 2. So we have a slope of 2. And now let's think about that. We have 2x minus 2. How would we graph that? Well, we'd find the y-intercept of -2. And we go right 1 up 2. That means we have a slope of 2 over 1. So we have a slope of 2. And so that's our first inequality, just y greater than or equal to 2x minus 2. The next one, it doesn't matter which one we do. Sure, I'll do this other one. Same process. We know that it's a solid line. So we're going to have y, and we know it's going to be or equal to, but notice that it's also shading above that line because it's shading everything in this little triangle up there. This is going to be y is greater than or equal to as well. Let's see if we can just work with the slope here. The slope here is right 1 but down 2. So right 1 down 2. So the rise is down 2, but we're going right 1. So the slope is just going to be -2. We have x, and then the y-intercept is +2. So we have y greater than or equal to -2x plus 2. And so there we go. That's our second inequality. The last one I'm definitely doing in blue instead of green because that was a nightmare. So with blue, this is just a horizontal line. So, and we notice that it's dotted. So we have y, and it's shading below that line, so we know it has to be just less than, and because it's dotted, it won't have the or equals bar under it. But then we just need whatever the y-intercept is, which is 2. And so it's just y is less than 2. And there we go. That's number 17. Number 19, pretty similar thing. I'll start with this vertical line here. All right, so we know that because it's a vertical line, it's going to be in the form of just x, and because it's shading to the left, left is going to be less than, and because it is a dotted line, it's going to just be less than. It won't have the little bar under it. And then we just need whatever the x coordinate is here, which was 1, 2. So we have x is less than 2. Next, I'll do this horizontal line. All right, so we know that because it's a horizontal line, it's going to be y. It's dotted, so it's going to be either a less than or a greater than, but not equal to. And because it's shading below, we know this has to be less than. And now we notice that the y-intercept of this is 2. So we have y is less than 2. The last part of this is we need this diagonal line. And so for the blue one, this is just, we're going to write y. It has a y-intercept of 0 and a slope of -1. Notice that we go over 1. So we have a run of 1, but a rise of -1. So we go right 1, down 1. That slope of -1 over 1 is just -1. And notice that we're shading above that diagonal line. So this is going to be greater than, and because it's solid, it's going to be greater than or equal to. We have a slope of -1, so I'll just write -x. And because we have a y-intercept of 0, we don't have to write the +0 there. We just have y is greater than or equal to -x. And so these are the three inequalities that describe this this graph. All right. For number 21, similar deal. We can pick any of these. I'll start with this one. Let's see. All right, so we have a dotted line and we're shading above. So we're going to write y is greater than, and our slope. What is our slope? Okay, so just starting from really any lattice point. Lattice points being where the grid lines intersect. But if I start from here, I see that I go right 1 and then up 2, right 1, up 2. So our slope, we go up 2 and right 1, so our slope is just 2. So we have greater than 2x, and then our y-intercept is at -1. So we have 2x minus 1 for this first line. The next one, I'll do this one. We have I'm going to write this as y. Notice that we're shading below, and it's a solid line. So it's going to be less than or equal to. The slope is going to be, we go right 1, down 1. So because we have a slope, we have a rise of -1 because we're going down 1 and then right 1. We have a slope of -1, which means that we have -x because we don't need to write -1x. And then we have a y-intercept of 4. So we have -x plus 4. The last one in blue, we have this line right here. This is a solid line, so we're going to have y, and it is shading above that solid line, so it's going to be y as greater than or equal to. Now this slope is the same as the other line, it's parallel, so it's still -1 over 1, so we have -1, and so a slope of -1, we're going to have -x, and then the y-intercept this time is a +1. And so this is the three inequalities that will describe this solution set. Alright, last one. I know this video is a marathon. We just hit the hour mark, but we're almost done. I'm hoping that this is more than enough detail and not enough detail for you to complete the assignment. I'd much rather I over-explain something than under-explain it. So hence why the videos are probably longer than if I was just lecturing in class for the same amount of material. But of course, these have to be a catch-all for any questions that could possibly arise. So in this case, we have three inequalities. Oh man, I have to use green again. So, oh well. Let's see. So for this first one, I'll start with this vertical line that's over here. Thankfully, because it's a vertical line, it's just going to be in the form of x. And notice that the shaded region is to the right of it. So that's going to be x is greater than, and then whatever this x coordinate is, this is going to be a -2. So x is greater than -2. Next one, I have this other vertical line. It is dotted and it's shaded to the left. So it's going to be a vertical line, so we have an x, and that's going to be less than for left, and then whatever the y, whatever the x-intercept is, which in this case is 3, so x is less than 3. Next, we have the blue line here. So this one we're going to have to write as y because it's not a vertical line. And the slope of this line, notice that if we start right here, we have to go over 2 up 1. So over 2 up 1, if we're going up 1, but we have to go to the right 2, that means that our slope is 1/2. And it is shading below that line, and it is a solid line. So it's going to be less than or equal to our slope of 1/2, stick the x on the end of that, and then whatever the y-intercept is, which is just 1, so plus 1. And now I have my green, my itty bitty bitty little pen. And so this is going to be our green line. Let's see, so the shaded region is above the line, and because it is solid, it is going to be y is greater than or equal to, and the slope here is over 1, so right 1, down 1. That means that our slope is going to be down 1, right 1. That's going to just be -1. So we don't have to write -1x, we can just write -x. And then our y-intercept is also a 1, so we have +1. And so that is the set of inequalities that will give this solution. So that concludes all of our examples for 2.4. So as usual, your homework is are the evens. So yeah, thank you for watching, and I'll see you in the next one.